We have question number 1 here as mathematical induction. I'm going to be solving, let's say, 5 to 6 questions based on mathematical induction. Now, the first question I have here says that it says, prove that for all natural numbers n, 5 raised to the power of 2n minus 1 is an integer multiple of what? Of 24. Solution. Now, considering this, we have some several steps to solve mathematical induction. And now let me decide to take step 1. What does step 1 say? Now, for step 1, we need to put when n is equals to 1. Now, considering this, when we decide to put n to be equals to 1, now let's check whether this statement is true. How will you go about that? Very simple. From the question, I was given 5 raised to the power of 2n minus 1. If I decide to put when n is equals to 1 in this expression I have here, automatically I have 5 raised to the power of 2, then times, since n is 1, I have my 1 here, then minus 1. This automatically gives me what? 5 raised to the power of 2 times 1 gives us 2, then minus 1. Then this should give me 25 minus 1, and I have what? 24. In conclusion, I can decide to say that this statement is true. It's true for what? For this condition I have here. For when n is equals to 1. That is for step 1. Now, for step 2. Remember, in step 1, I use when n is 1. Now, for step 2, I need to make an assumption. I need to assume. Now, if I decide to say, assume that this statement I have here is also true for when n is equals to what? When n is equals to k. This is the next condition. The next assumption, you put when n is 1, and automatically I have 24. Now the second step is I'm trying to assume for when n is what? When n is k. So guys, if I decide to put when n is k into this expression I was given, 5 raised to the power of 2n minus 1, then I'll have something like this, 5 raised to the power of 2, where n is what? Is k. Then minus 1 is equals to what? I don't know. But I can actually say that I have the result to be 24 being multiplied by any natural number. I can decide to represent a natural number by what? By big M. So I can easily say for somewhat, I can decide to say this M represents some for some natural number n. Yes, for some natural number n. So this is the logic I'm going to be using, this concept. First, you put when n is 1. Second, I need to put when n is k. And then when I put n to be equals to k, I'll make it to be equals to the integer multiple of 24 that was given. At it being they said this expression is being divisible by 8, automatically I write 8m. Now the question says is an integer multiple of what? Of 24. That is, I can easily write 24 and multiply it by any letter, and I represent that letter as what? As a natural number. Now when you get to this stage, then I'm good to go. Now let me move to step 3. For step 3, what I just have to do is that I really need to consider when n is equals to, no, actually I use k. Now when n is equals to k plus 1, just a shift of 1 in k. Then what do I have? Then remember that the expression given is 5 raised to the power of 2n minus 1. So if I decide to put n to be equals to k plus 1, then class, I have 5, I have 2, then my n is what? K plus 1. Automatically, minus what? Minus 1. And the same way, I can also say this is equals to 5 raised to the power of 2 times k is what? 2k, plus 2 times 1 is what? 2, minus 1. As a mathematical student, I believe that from indices, the rule of indices, I can decide to write this 5 raised to the power of 2k plus 2 as 5 raised to the power of 2k multiplying 5 raised to the power of 2 class. So, you know, the rule of indices states that whenever you have an index in number or an exponential with the same base, and if those bases are being separated by a multiplication sign, you add their powers together. So this gives us this back, minus 1. But class, remember, I can easily remind you that this 5 raised to the power of 2k can be gotten from here. If I decide to make 5 raised to the power of 2k as subject of formula in this case, what will actually happen is this goes to this side, and I'm going to have 5 raised to the power of 2k equals 24m minus 1. Good. All I will just have to do now is, since 5 raised to the power of 2k is equals to this, I'm going to substitute the value into 5 raised to the power of 2k. So I'm going to have this representing 24 big M minus 1. And at the same time, it's multiplying 5 raised to the power of 2 minus 1. So what am I going to do from here? All I just have to do is, I have 2. Okay, class. I have, when this minus goes to this, I have plus 1. So I have to expand the bracket. Now, recall that from 5 raised to the power of 2k multiplied by 5 raised to the power of 2 minus 1, I can easily recall that this 5 raised to the power of 2k is equals to this, right from when we put n equals to k. I'm sorry for the mistake I made. This should be plus 1. Now for that, all I just have to do is, if I decide to open this bracket, open it up, and I'll have something like 5 raised to the power of 2 multiplying 24n. Good. Then I have this 5 raised to the power of 2 multiplying 1. That also gives me 5 raised to the power of 2. And I have minus 1 here. So, trivially, I have 5 raised to the power of 2 as 25. I have 24m. Then plus 5 squared is 25 minus 1. Trivially, the result gives 25 times 24 big M plus 25 minus 1 gives me plus 24. From here, I can easily say that 24 is a common factor between these two expressions. If 24 is a common factor, I'll be left with 25m and 1. This divide this. And that should be 25m plus 1. Which is a multiple. Which is a multiple of what? Of 24. 24 is multiplied by this. This shows. The expression that I've done so far here, it shows that the statement is true for n equals to k plus 1. So in conclusion, I can easily say that hence, by the principle of mathematical induction, the statement given in the question, the statement 5 raised to the power of 2 and recall minus 1 is true, is absolutely true for what? For all natural number n. So that is the conclusion I can easily make.